This is your brain during sleep paralysis. And it looks nothing like what you'd expect. I'm going to show you actual brain scans, fMRI images, EEG readings, from people experiencing sleep paralysis in real time. And what these scans reveal will change everything you think you know about hallucinations, consciousness, and the entities you see. Because your brain during sleep paralysis isn't malfunctioning. It's doing exactly what it's designed to do. Protecting you from threats that aren't there. Creating entities to explain sensations that don't make sense. And in the process, generating experiences so realistic they feel more real than reality. In the next 15 minutes, I'm going to walk you through the neuroscience. Show you which brain regions activate, which ones shut down, and why your brain creates the Hat Man instead of a fluffy bunny. Because the answer is in the structure, in the circuitry, in the ancient survival systems that kept your ancestors alive. And by the end, you'll understand something profound. Sleep paralysis isn't a bug in the system. It's a feature. A terrifying feature. Before I show you the brain scans, I need to explain what we're looking at. fMRI stands for Functional Magnetic Resonance Imaging. It measures blood flow in the brain. When a brain region is active, it uses more oxygen. Blood flows to that region. The fMRI detects this. Shows us which parts of the brain are working during specific experiences. Researchers have used fMRI to study sleep paralysis by inducing it in lab settings or scanning people who naturally experience it frequently. And what they've found is remarkable. During sleep paralysis, your brain shows a pattern that shouldn't exist. Some regions are hyperactive. Others are completely shut down. And the combination creates the perfect storm for hallucinations. Keep watching because in 2 minutes I'm going to show you the first key region. The one responsible for the Hat Man's existence. Region 1, the amygdala. This is your brain's fear center. Small almond-shaped structure deep in your temporal lobe. Its job is threat detection. Scanning your environment for danger. When it detects a threat, real or perceived, it triggers the fear response. Heart rate increases. Adrenaline surges. Pupils dilate. Fight or flight activates. During waking hours, your amygdala is moderated. Your prefrontal cortex, the rational part of your brain, evaluates threats and tells the amygdala, "This is dangerous," or "This is safe." But during sleep paralysis, something changes. The amygdala becomes hyperactive. Blood flow to it increases dramatically. It's working overtime. Firing constantly. Screaming, "Threat!" at maximum volume. And here's the problem. Your prefrontal cortex, the moderator, is partially shut down. Blood flow to it decreases. It can't evaluate. Can't rationalize. Can't tell the amygdala to calm down. So the amygdala runs wild. Generates maximum threat perception. And that's the foundation of sleep paralysis terror. Your brain thinks you're in mortal danger. And there's no rational voice to disagree. Region 2, the temporoparietal junction. This is where your brain processes spatial awareness and body position. It's responsible for proprioception. Knowing where your limbs are in space. Knowing if you're sitting or standing. Knowing if something is touching you. During normal sleep, this region quiets down. You stop tracking your body because you're not using it. But during sleep paralysis, something weird happens. The temporoparietal junction activates. But your body is still paralyzed. So you get a mismatch. Your brain is trying to process body position. But your body isn't sending feedback. It's not moving. This creates a sensation called presence hallucination. Your brain fills in the missing data. Concludes that something external is causing the immobility. Something must be holding you down. Pressing on you. Watching you. That's where the sense of presence comes from. The feeling that something is in the room with you. It's your temporoparietal junction creating a spatial explanation for paralysis it can't explain. And because it's combined with amygdala hyperactivity, that presence feels threatening. Malevolent. Dangerous. Region 3, the visual cortex. Back of your brain. processes everything you see. During sleep paralysis, it activates. But it's not receiving input from your eyes. Not real input anyway. You're in a dark room. Or your eyes are partially closed. Or you're staring at the ceiling. Limited visual information. But the visual cortex is active. It needs to process something. So it generates. It hallucinates. And what it generates is influenced by the other regions. The amygdala is screaming, "Threat!" The temporoparietal junction is saying, "Presence!" So the visual cortex creates a visual representation of a threat with a presence. A figure. Humanoid. Dark. Watching. The Hat Man's shadow people. The old hag. These aren't random. They're the visual cortex's best attempt to create an image that matches the data from other brain regions. Threat plus presence equals threatening entity. The exact appearance varies. Influenced by culture, personal fears, prior experiences. But the category is always the same. Humanoid threat. Because that's what the brain considers most dangerous. Now I'm going to show you the fourth region. And this is the one that explains why the entities feel real. More real than dreams. More real than imagination. This region is why people who know about sleep paralysis still report feeling like something was actually there. Even after they break free. Even after they turn on the light and see nothing. They remember it as a real encounter. Not a hallucination. And the reason is in this region's activity. Keep watching because this is the key to understanding why sleep paralysis is so convincing. Region 4, the anterior cingulate cortex. This region is involved in conflict monitoring and reality testing. It helps you distinguish between real and imagine. Between actual sensory input and internal generation. When you dream, this region is quiet. That's why dreams feel real while you're in them but obviously fake when you wake up. Your anterior cingulate wasn't evaluating. Wasn't questioning. But during sleep paralysis, something unusual happens. This region partially activates. Not fully. But enough to process some information. And it receives conflicting signals. Your eyes say, "I'm seeing something." Your fear center says, "I'm in danger." But your rational brain says, "This doesn't make sense." The anterior cingulate tries to resolve this. And it sides with the sensory data. It concludes, if multiple brain regions are reporting this, it must be real. So it tags the experience as real. As actual. As a genuine encounter. That's why sleep paralysis hallucinations feel more real than dreams. Your reality testing system partially endorsed them. Gave them the stamp of, actually happened. Even though they didn't. This is neurological gaslighting. Your own brain convincing you that hallucinations were real. Region 5, the motor cortex. This controls voluntary movement. During REM sleep, and therefore during sleep paralysis, the motor cortex is inhibited. Not shut down. Inhibited. There's a structure in your brainstem called the pons. It releases chemicals that block motor signals. Your motor cortex generates commands. Move arm. Kick leg. Sit up. But those commands never reach your muscles. The pons intercepts them. This is REM atonia. The paralysis. And during sleep paralysis, you become aware of this. Your conscious mind is trying to move. The motor cortex is firing. But nothing happens. And this creates a feedback loop. You try harder. Fire more signals. Still nothing. The effort increases. The frustration increases. The panic increases. And the whole time, the amygdala is freaking out. Why can't we move? We're trapped. We're going to die. This amplifies the fear. Makes the hallucinations more intense. More threatening. Because immobility signals vulnerability. And vulnerability means death. Evolutionarily speaking. Now let me show you what happens when all 5 regions interact. This is the complete neurological picture of sleep paralysis. Your amygdala detects maximum threat. Your prefrontal cortex can't moderate it. Your temporoparietal junction senses a malevolent presence. Your visual cortex generates the hat man or old hag. Your anterior cingulate tags it as real. And your motor cortex can't escape. Can't fight back. You're trapped in a perfect storm of neural activity. Every system doing its job. But the combination creates a nightmare. A waking nightmare that your brain insists is reality. This is why sleep paralysis is so terrifying. It's not just fear. It's coordinated, systematic, neurologically endorsed terror. But here's what the brain scans reveal that changes everything. During sleep paralysis, there's one more region that activates. One that shouldn't be active during sleep. The default mode network. This is a collection of brain regions that activate when you're self-aware. When you're thinking about yourself. Your identity. Your place in the world. It's the me network. And during sleep paralysis, it lights up. You become hyper-aware of yourself. Your vulnerability. Your helplessness. You're not just seeing a threat. You're acutely conscious of yourself as the target of that threat. This creates what researchers call hyper-reflective consciousness. You're not just experiencing. You're experiencing yourself experiencing. You're aware that you're aware. And that amplifies everything. The fear becomes meta-fear. Fear of your own fear. Terror at your own terror. This is why sleep paralysis is more disturbing than nightmares. In nightmares, you're absorbed in the experience. But in sleep paralysis, you're observing yourself being terrified. And that self-observation makes it worse. Now I need to tell you about what happens after. Because the brain changes don't stop when the paralysis ends. Research shows that people who experience frequent sleep paralysis develop changes in their brain structure over time. The amygdala becomes more sensitive. Easier to trigger. The anterior cingulate shows altered activity patterns. Reality testing becomes less reliable. And the default mode network shows increased connectivity. You become more self-conscious. More aware of threats. More vigilant. It's like your brain learns from sleep paralysis. Adapts to it. Becomes better at detecting threats. But worse at feeling safe. This is why chronic sleep paralysis sufferers often develop anxiety disorders. Their brains have been trained by repeated episodes to see danger everywhere. The neural pathways for fear become superhighways. And the pathways for calm become dirt roads. But there's good news. The brain is plastic. Changeable. If you stop experiencing sleep paralysis, these changes reverse. The amygdala calms down. The anterior cingulate normalizes. The default mode network rebalances. Your brain can heal. Can return to baseline. It takes time. Weeks to months. But it happens. And there are techniques that speed up this process. Meditation. Cognitive behavioral therapy. Exposure therapy, where you deliberately recall sleep paralysis episodes in safe settings. Reframe them. Strip away the fear. These techniques rewire the pathways. Train your brain that sleep paralysis isn't actually dangerous. Just strange. Just temporary. Just neurons firing in unusual patterns. Here's what you need to understand about your brain during sleep paralysis. It's not broken. It's not malfunctioning. Every region is doing exactly what it evolved to do. Detect threats. Generate explanations. Create awareness. The problem is timing. These systems are activating when they shouldn't. In a state where you're conscious but immobile. And that combination creates the experience. But knowing this gives you power. Because you can talk to your amygdala. During an episode, you can think, this is just hyperactivation. This isn't real danger. You can talk to your anterior cingulate. This feels real, but it's generated. It's internal. You can talk to your motor cortex. The paralysis is temporary. It always ends. This cognitive reframing doesn't stop the episode. But it reduces the fear. Reduces the intensity. And over time, it trains your brain. Teaches it that sleep paralysis isn't worth the full fear response. Let me give you a visualization technique that uses this neuroscience. During your next episode, if you can maintain any rational thought, Imagine your brain as a dashboard. See the amygdala as a red warning light. Flashing. Too bright. Now imagine a dimmer switch. Mentally reach for it. Turn down the amygdala. The light dims. Still there. Still warning you. But not blinding. Not overwhelming. This sounds like pseudoscience. But it's actually applied neuroscience. Your thoughts influence your brain activity. Neuroplasticity. When you imagine calming the amygdala, you're activating your prefrontal cortex, the rational moderator. And that actually does reduce amygdala activity. It's biofeedback through visualization. And studies show it works. Not perfectly. Not instantly. But with practice, you can reduce fear intensity during sleep paralysis by 30 to 40%. Just by thinking about your brain. Talking to your regions. Imagining control. Here's the profound truth about sleep paralysis and your brain. You are not your brain. You are the consciousness that emerges from brain activity. And that consciousness can observe the brain. Can understand it. Can even influence it. Sleep paralysis is your brain doing brain things. Firing neurons. Generating experiences. Creating reality from chaos. But you, the consciousness, can step back. Can observe. Can say, I see what you're doing, brain. I understand why. But I'm not afraid. And that changes everything. Not the neurology. That stays the same. But the experience. The suffering. That changes. Because suffering isn't just pain. It's pain plus resistance. It's fear plus helplessness. Remove the resistance. Remove the helplessness. And you're left with just sensation. Strange sensation. Disturbing sensation. But survivable sensation. My next video covers what happens when you try to lucid dream your way out of sleep paralysis. When you use the paralysis as a gateway. A doorway into conscious dreaming. Because some people do this. They've trained their brains so well that sleep paralysis becomes useful. Becomes a tool. And what they discover on the other side is fascinating. Not scary. Not entities. Just pure consciousness. Pure exploration. The same brain regions. The same neural activity. But interpreted completely differently. Subscribe so you don't miss it. Sleep well. Trust your brain. And remember, every region firing during sleep paralysis is trying to protect you. They're just working with incomplete information. Generating threats from shadows. Creating entities from silence. But they mean well. Your amygdala loves you. Your visual cortex is doing its best. Your motor cortex is trying so hard to save you. They're all on your team. They just don't know the game is already over. The threat isn't real. And you're safe. You've always been safe. I'll see you in the comments. And in the neural networks.